Hello, welcome back to our channel. I am Anisha, your maths faculty for class 12. We have started chapter number 5 of class 12, that is continuity and differentiability. We have started solving the exercise 5.1 of this chapter, and I think we reached up to question number 22. Now, in this video, we're gonna do question number 23 and 24 of this exercise 5.1. Let's begin. Okay, so what is question number 23 of exercise 5.1? Here, what we have to do, we have to find all point of discontinuity of function f where our f is defined like this. Okay, as you can see, your f of x is defined as so I have already told you whenever you have a function like splitting of a function, you have to divide the function in the case like you have to divide the checking of the continuity in cases. First, like before that point, particular splitting point, after that first splitting point, and exactly on that splitting point. So here will be our case one. So let's begin. So our case one. So case 1, when my x is strictly less than 0. So when my x is strictly less than 0, my function is defined as f of x is defined as sin x by x. Now, as you know that, you can see my f of x function is defined like sin x by x. This is my sum function, this is my sum function, and we know that sin x is continuous and x is continuous. I hope you guys also know that that sin x is a continuous function for all its domain and x is continuous function all its domain because it is like trigonometric function. It is trigonometric function and it is like polynomial. And we know that if I like make a note point for you, I have, if you like don't know that like from where you have like it's very easy till now that any ax plus b is a continuous function because of they are polynomial kind of function. But now you should also remember that any trigonometric functions are continuous in their domain, in their particular domain. So um if I like make you a note point that sin x and cos x are continuous functions on whole R. Okay, so by using sin x and cos x, you can find like continuity of any different trigonometric function by using the algebra. So here also we will gonna use this algebra that we know that for any x, for any, let's say x equals to c, which is like c is greater less than 0, we know that our sin x and x are continuous at x equals to c. By using the algebra of continuity, we can easily say that my f of x function, which is defined as sin x by x, will be continuous at x equals to 0. What we are using, because we always, you should write your reason in mathematics. The see, mathematics is a very simple language. Whatever you do, you are doing, whatever you are like writing, you should explain in like short way as a reason for why you are using this. So here what we are using, if f and g are continuous at x equals to a, then by using algebra, f of f by g is also continuous at x equals to a, where my g of a is not equal to 0. If my g of a is not equals to 0, as you can see, when my x is strictly less than 0, so x is c, where which is strictly less than 0, which is not 0. So by using that, what we have find that by using algebra, we can easily say that sin x by x is a continuous function for any x equals to c. So what we have find from here, what we have concluded that f is continuous for any x less than 0. Now move to case 2. What is case 2? As you can see, case 2 is very simple for you, like piece of a cake for you right now, because as for x strictly greater than 0, it's a polynomial function, and we know that every polynomial function is continuous on whole R. So here we only have to see for x. So if I like try to write our case 2 only. So what is our case 2? Our case 2 is for x is strictly greater than 0. We know that for this, our f of x is defined as x plus c, x plus 1. And we know that polynomial functions are continuous on whole R. So by this, by using that result, we have f is continuous for any x less than 0. Sorry, here it is greater than 0. Sorry, this is the case when it's just polynomial. We don't have to, I am not giving a stress on that because I think it's very easy for you. I should like mention the like parts that are not trivial for you guys. So that is the case 3. What is case 3? We have to check the continuity at x equals to 0. For that, we will find the function value, as the function is, as you can see, our function is defined on that, and it is defined as x plus 1. So this will be 0 plus 1, which is nothing but 1. Our function value is 1. So now let's find the limiting value. That means limit of x tends to 0, f of x. We know that our function for, like, when we are coming from the left, it is defined like sin x by x, and when we are coming from the right, it is defined as x plus 1. So we should find our left by like limit by using like left hand limit and right hand limit. So if we start with left hand limit, and it will be nothing but limit of x tends to 0 minus sin x upon x. And we know that when x tends to 0, sin x upon x, this is a very standard like limit uh, finding of limit, that is limit x tends to 0 sin x by x. We know that this is nothing but 1. Okay. So this limit is 1, left hand limit is 1. Now let's move to right hand limit. We know that our right hand limit, it will be defined as limit of x tends to 0 positive x plus 1, which will be nothing but 1 as x tends to 0. So our left hand limit and right hand limit both are same and both are equal. So by this what we get, our function value f of 0 is same as limit value, that is limit of x tends to 0 f of x, and both are nothing but 1. So by from here also what we have concluded, that the function f is continuous at x equals to 0. So from all these cases, what we have concluded, that the function f is continuous for all x belongs to domain. Here our domain is nothing but whole R. So from here what we get, f is continuous on a whole domain. So therefore f is continuous function. What we have, this is our conclusion. Like, as you can see, maths is very easy language. What you have to do, just do it. If you are using some results, just write your reasons. There is nothing much hard rule there in there. Okay, so we are done, right? Now let's move to question number 24, as we are done with 23. So let's move to this question. In this question, we have to do the same thing. We have to determine the continuity of the function. Okay, okay, I think in 23 we have to find all point of discontinuities, right? But as you can see, there is no point of discontinuity. As you can see, there is, the function is continuous at everywhere. So from here from here what we have concluded, so conclusion is no point of no point of discontinuity. Now let's move to question number 24. Okay, so in question number 24 we are given with a function f of x is defined like this, and we have to check the continuity of a function. Now as you can see, I'm not gonna do all like checking the continuity at each and every point. We gonna use some tricks. What we will do, that for x equals to 0, the function is defined as, okay, so it's very easy. Now you can see, for x equals to 0, I did mistake. There no need of this graph. There is no need of this graph. Okay, so as you can see, the function is defined as x square sine 1 by x if x is not equals to 0, and 0 if x is equals to 0. Okay, we know that for any x belongs to real, 1 upon x is defined except at x equals to 0. So if 1 upon x is defined, so 1 upon x is just our, what is this? If x is a real number minus 0, then 1 upon x will again a real number. Okay, so if we like, it will be a real number. Now we know that sine is defined for all real number, and sine is continuous for any sine is continuous at any real number. X square is also continuous at any real number. Now what you will do, whenever you know that like if your function is like coming from sum of two functions, product of two functions, or maybe division of two functions, so you can use your algebra of limit directly. So by using algebra of limit, take my, say, h of x as x square, my g of x as sine 1 by x. Okay, now we know that this is continuous because it is polynomial for all x not equals to 0. We know that this is continuous for any x not equals to 0. So from here, by using the, let's fix for some c belongs to real minus of 0, my h and g both are continuous. So by this, my h of x plus g of x is continuous at x equals to c. So by this, what we mean that my f of x, which is defined nothing but my h of x is, sorry, it's not summation, it's product, sorry, product. By using algebra of product. What is that product? When my h of x is continuous, my g of x is continuous at particular point, then their product is also continuous. So by using that, what we get, our x square multi sine of 1 upon x is continuous for any x not equals to 0. So we are defined, like what we are done, that the function f is continuous for all x not equals to 0. Now we only have to check the continuity at x equals to 0. So at x equals to 0, what will be this? So for that, first we find function value. We know that f of 0 is defined as 0 for x equals to 0. Now limit value. As you can see, we have to find limit of x tends to 0, x square sine 1 upon x. Now we have to find its limit. Maybe some of you guys know this very easily, but let me explain you if few of you will not know this. So what we will do, so this limit can be, we know that when x tends to 0, x square tends to 0, but we don't know about sine 1 upon x, because when x tends to 0, 1 upon x is infinity. So this is sine of infinity. We don't know what it is. But what we know is sine is bounded. Like sine of theta, sine theta take the value in -1 to 1 only. So what we can say, our sine of 1 upon x is greater than equals to -1 and less than equals to 1. So by this, what you get, multiply both side by x square. X square is a positive number. So what we can do, we can just easily multiply both sides in all sides. So what we get, minus of x square is less than equals to x square dot sine of 1 upon x less than equals to x square. So what we get, this we get this, what we get, it is kind of sandwich. We have to find this. If we find this, and if both of these limits are same, then this limit should be same as this number, right? So it's nothing but we are using sandwich rule. What we are doing, just sandwiching a particular term between two terms which are having the same value. So we know that when limit, apply the limit both sides, the limit of x tends to 0 minus x square is less than equals to limit of x tends to 0, x square dot sine 1 upon x less than equals to limit of x tends to 0, x square. We know that when x tends to 0, x square also tends to 0. 0 is less than equals to limit of x tends to 0, x square dot sine 1 upon x is less than equals to 0. So what you get, this limit is nothing but 0. So from here, what we get, this limit value is nothing but 0. As you can see, the limit value and function value are same. So from here, what we get, there is, I think, you you will easily guess that f is continuous at x equals to 0 also. So from here, what we did, in the previous part, this part, what we in this part, what we did, that the function is continuous for all x not equals to 0, and this, in this part, what we did, that the function is continuous at x equals to 0. So from this, what will be our conclusion, that f is continuous for any x belongs to real number. So this means f is continuous in its whole domain. That means f is continuous function. When the function is continuous in its whole domain, we only mean this as a continuous function. So from here, what we determine, that f is a continuous function. Okay, so we are done with the question number 21, 23 and 24. This types of, this are using of algebra, you now, your level of the questions will increase. From question number 1 to, I guess, 20, you have very basic questions where you just have to apply your definition, find your limit. But you cannot do applying your definition every time, because it will be very terrible job for you. But if you use your algebra of limits, if you know some that this function is continuous, this function is continuous, but now you have to find the sum of sum of these functions. So you can use your algebra. Like now onward, what you have to think was like if you can easily apply your algebra of continuity or not. So this is the case where like algebra of continuity is very useful. So this type of question, like you can make many questions by using this, where you have to just use your algebra of continuity and you can find the like you can check whether the function is continuous or not. So we are done. Now that's all for today's video. We will meet tomorrow in next questions of this exercise. I think very lot of questions are remaining till now, but please do these questions by your own. If you are like try to use your algebra of continuity very often, so that you will be very useful for the useful by using that the so can you can easily click like yeah, you can use your algebra of continuity here. You can use like you can split these functions into sum of two functions, product of two functions, like that. So it will be very helpful for you. So please keep practicing and keep watching the videos. If you have any doubt, please ask me in the comment section, and I will like solve your doubts as soon as possible. Till then, goodbye. Please like, share, and subscribe this video so that you can easily come to this YouTube channel very oftenly. Thank you.